I assume this is the crowd, and that's probably appropriate for the discussion today. I appreciate your being here. My name is Dan Haas. I am from Peraton. We submitted a few answers to the questions that were supposed to drive these, the responses, and we had our response selected. I am representing a team that put together our solution to address the issue of ingesting sensor feeds from multiple enclaves into a single platform. Okay. Now, I will tell you that my background is not technical. I am an operator by background. I've been working in cyber for several years now. What we chose to do when we took a look at this was really to get to the operational aspects of ingesting sensor data and actually employing it to operational effect. That was our focus. And so what we really took a look at was focusing on the foundational requirement for a data fabric to make data that you do collect from sensors operationally relevant. And what I'd like to do is present a framework for that data today. Why the concern with data in a data fabric, and especially a single data fabric? But quite frankly, if you look at where the services are going, if you look at where conflict is going, if you look at the way we are setting ourselves up, what we are really doing is we are preparing to engage in what I would term a contest of command and control. It will be a competition that will determine winners and losers, and the winners will be those who can sense, understand, decide, act, and repeat that with meaningful data at a tempo that outpaces their adversaries. And over time, their adversaries' decisions and actions will become less relevant, while the speedier will actually dictate the action and will ultimately prevail. Our goal should be to provide the data that is required to support that sensing, understanding, deciding, and acting at tempo, sustained over a geographically dispersed force that is far from our home and far from the infrastructure that we might hope for, in a way that is effective in foiling our adversaries' plans and achieving our outcomes. So that is the tack that we took. That's what we looked at as we walked through the problem, and that's how we addressed it, and that's what you'll see a summary of today. So we'll create that. We've created that framework, and we'll provide it to you. I think from a technical perspective, it's going to be an extraordinarily challenging problem as we move forward, because we have, as you know, you can just go look around the floor, we will have a proliferation of sensors. We will have exponentially increased data over time that we will need to make use of. Or quite frankly, it's an opportunity cost for us at operations that decreases efficiency, decreases effectiveness, and increases our operational risk. We will have a problem here, or a solution here today, that when we discussed it, we were primarily talking about the cyber, we started talking about the cyber domain, but quite frankly, the concept and the framework will employ to operations in any domain, because we do have sensors in any domain. So we tried to generalize it a little bit. So I will walk through it. I will try to take about my 15 minutes, 15 of 20, and leave a little bit of time for questions at the end. I should have a couple of people, a couple of technical folks down here to answer questions. And if not, you can stop up at the Peraton booth and I can engage them up there. All right? So that's the framework. So what are we looking at when we're talking, though, about a data fabric? Let's start off with a common data fabric. As we look at this slide, I would ask you to look at the center, and you'll see 6 hexagons. Starting from the upper left hexagon, these are what we consider to be the essential elements of a data fabric, okay? The first one on the upper left is data ingest. Data ingestion is where you take data from multiple sources or sensors of multiple types. Data that has been previously stovepiped by the systems in the structure in the way that we have set them up, and you can ingest them into a platform. The second point is you work clockwise as data discovery. And what we want to do there is we want to employ data modeling, preparation, and curation in this aspect or this element of creating your data fabric. It allows your analysts to find and consume data across the silos as if they were part of the same data set originally, providing access that will enable you to draw insights from the data that you would not have as you looked at the siloed data on its own. Going to the right again, you have data processing. Data processing is where you truly curate and transform the data, and it's where you have a set of tools that allows you to do so and make it analytics ready to be used by downstream tools and analytics. To the right again, as you go down to the lower right, is your data management in Intel. And that's where you're able to secure your data and enforce governance. This is where, from across multiple enclaves, you can make the determinations of who can access data, who cannot access data, who has the need to access data, and quite frankly, it lets you apply global structures such as metadata management. It enables search, and it enables lineage control. On the bottom center is where you have data orchestration. And that's the component of building your data fabric that allows you to coordinate the operations of all stages through an end-to-end data workflow. So data orchestration really outlines the mechanics. It lets you define when and how often you should run the pipelines and how you can manage the data produced by those pipelines. Very important consideration when you're looking at your data orchestration is you need to have your operational objective in mind. Everything you do with data has to be focused at an outcome. If you're working data for data's sake, then you are unfocused and wasting time, right? If you know what your operational outcome is in whatever domain you are collecting that data, or multi-domains where you are collecting that data, then you will be able to shape your data to your ends. And that's incredibly important when you're seeking efficiency and effectiveness in an adversarial and competitive environment. You need to know the outcome you seek to shape the data that you intend to employ. To the right of that, you'll see data access. Data access, as we look across, is the sixth that we talked about, and this is where you deliver your data to analysts directly. It can be push or through queries where they can tailor the queries based on their functional requirement or their operational requirement, depending on where they sit. It's where you will employ your APIs, your data services, and where you will build your dashboards. This layer often bundles semantics or builds semantics, intelligence, and puts rules into data access mechanisms that allow you to provide the data in the required form and format that is usable by the human being who is going to make use of that data for decision making. So again, those are the 6 fundamental elements. What I'd like to do next is I'd like to introduce another model. And this is our conceptual data fabric architecture. If you look at this, this really kind of illustrates, rather than a foundational and outbuilding portrayal of what we essentially were defined as the essential elements, this is where you illustrate the process of establishing and maintaining a data fabric really in sequence. So this is intended to be a rough timeline from your left to your right. And we'll start with, you have to start with multiple data sources. And that's where, again, we were looking at a broader than just C5ISR type sensors, but we started with the cyber flavor, so that's why you can look. And that's where you have, SaaS, ERP, web, social, commercial, open source. There are any number of data sources that you can fit in there that come in multiple streams. You have qualitative data, quantitative data, open source, and you can have your exquisite data, your data that comes from purpose-built sensors to go after your targets and your particular targeted capabilities that the adversary may have. So we take those and we work through data acquisition. I talked a little bit about ingestion, right? And the topic of the paper was supposed to be ingestion, but ingestion was a very small technical part of building a data fabric. And so for operational capability, what we wanted to do was expand a little bit, and so we talked about data acquisition. So when we talk about data acquisition, we're really talking about bringing those data sources then ingesting them into the platform, and it can be streaming data. It can be data that is pulled from one place to another in the organization. It can be data that is sent in bulk to the sensors. Again, it's all purpose-built depending on what you would need, and quite frankly, your ability to transmit it. So when we start to talk about the DDIL environment, when we talk about interrupted communications and the need to sustain continued operations, making decisions about your data sources, your data acquisition methodologies, and then your storage and refinement are critical to what your operational requirements are. If you think about what the challenge is as we look at great power competition, the geographic dispersal, the amount of sensors we will have on the battlefield, and the contested space that we will have that will affect our ability to gather data and have data and compute power where and when we want it to sustain operations is critical. So those decisions need to be focused around operations and operational requirements and the operational environment. So when you start to talk about data storage and refinement, we can talk about data lakes. We can talk about operational stores, master data, preference data. The bottom line is the key is to determine where you need what data, where you need metadata, and where you need the compute to be able to sustain your operations in a contested environment. So again, those within that box, there are going to be some critical decisions that are driven by operational requirements. To the right of that, we have data access, and that's where we start to look across. We start to catalog the data. We start to apply data governance and data security. So this is where we start to make the data usable. We start to provide the opportunity to start developing insights and drawing those insights from your data. And then finally is data consumption, and that's where you apply your data science, business analytics, and business intelligence reporting to provide your recommendations, analysis, and outcome to feed into that understand, decide, and act. If you look across the bottom, you can see that it's supported, but this can occur using multiple platforms, whether it's on-premises, hybrid, cloud, multi-cloud, or quite frankly, pushing it out to the edge. And again, the distribution among those various platforms is going to be driven by your operational environment and your operational requirements. You'll notice if you look down on the bottom that you've got 5 of the 6 elements or blocks, and the one that is missing is data orchestration. The reason data orchestration is missing is because it is inherent in the activities that you have in that top block moving from left to right. So when we take our model and we apply it in an Army context, this is where we start to look at applying our data sources to specific sensors. If we're talking about space, cyberspace, air, land, and sea, again, sensors from any domain, so we're taking a multi-domain approach to our modeling that will provide you data sources, and we have a multiplicity of types of data that you will collect on the typical operational environment. It could be pulled from the cloud, it can be pulled from files, it can be network data messaging, or big unstructured data. We then start to look at data acquisition, and we talk about data in motion. So largely, if we're going to start supporting dynamic operational requirements, we're really talking about pulling a lot of being able to move data from one place to another in the organization, to extract, transform, and load data, and replicate data, and change capture in order to meet our needs. Data storage and refinement on the right-hand side. Again, we can work across all. You have to work across all enclaves, and that's your unclass, your secret, and your TS. And again, we have structured, semi-structured, caching, and open storage. As you move into analyze, that's where you want to have your query virtualization dashboard and data services that I mentioned before. And ultimately, data consumption on the right-hand side, that's where we run our business analytics, our business intel, and our reporting. Of course, all of that is going to be driven, again, by your data orchestration in terms of mechanics, and it's going to be constrained or enabled by your data governance that you establish beforehand. I emphasized it before, and I will do so again, that all of that needs to be operationally aligned to the needs of the warfighter. And quite frankly, that is from sustaining operations forward and then pulling it back. Ultimately, if you're to do this in a way that meets an operator who is not a data scientist or a data operator, what you're going to want to be able to do is take that data then and portray it in a usable form for whoever your audience is, whether it is a commander who has to take a holistic view of the environment, whether it is a functional specialist who's got to take a focused view on particular aspects of the data and have their own analytics providing that aspect that builds up into serving that holistic environment. Quite frankly, the ability to display the data and the analytics that you have developed and provided is critical to achieving the operational outcome that you wish in the time that is relevant for the operational environment. And again, to speed or accelerate that sense, understand, decide, act loop for a sustained period of time to outcycle your adversary. When you take a look at the ability to take structured data, unstructured data from various sources, to put it all together into a simple, common picture in a readable format that can then be displayed in a human ingestible or cognitively ingestible form, that is the critical element from soup to nuts. The mechanics that have come up to this point are all useful. They're necessary, but they are insufficient to actually enabling operations. So we have developed our certainly, and I know many others have developed their visualization models and capabilities, and quite frankly, the ability to bring those to the customer in ways that are relevant to their operational requirements, are things that will enable us to affect operations down the road. So, 18 minutes went kind of fast. I apologize for that. But I will say in conclusion, right? Data Fabric enables command and control advantage, because we will be in a command and control fight. It accelerates the sense, understand, decide, and act tempo. A common data fabric serves to eliminate the silos that are structurally created by the systems that we have invested in and built, that are designed to operate on their own or that are functionally oriented. It allows the commander and the commander's staff to gain common understanding to support operational decisions at speed, increasing operational efficiency, effectiveness, and reducing operational risk. We provide data accessibility by following the Vaultus methodology, for those who have done data science before, to make the data visible, accessible, understandable, linked, trustworthy, interoperable, and secure. So that is across all those silos of data. And I didn't talk distinctly about trustworthy and secure, but those have to be inherent in the design of your data systems, in your governance, and quite frankly in your orchestration. And it needs to serve ultimately as a single source of truth when you have achieved those Vaultus goals. And then finally, we see the chief benefit of taking the time to develop and to execute the plan for creating a data fabric and doing the analysis that determines what you want where or need where is critical to accelerating command and control and prevailing over our increasingly capable adversaries. Okay, with that, I will open the floor for any questions or comments. Yes, sir.
I just want to ask about, sir, on your previous diagrams, right, on the ingestions, I don't see any area where, data, somewhere, yes, here, where do data cleansing or data standardization, because it comes from sensors, right, and it's basically, we can talk dirty data, right?
Right.
So before you kind of proceed with your, workflow, it needs to be kind of standardized somehow or cleansed somehow. Is it stuck, it intentionally missing, or it's something like just?
So where we put that was ultimately in the data storage and refinement. You collect from your data you do the acquisition, it's under storage and refinement when we bring it in. That's where we'll do actually the cleansing and the transformation of data into what would be more common usable forms. Does that answer your question? Anybody else? Yes, sir.
Yeah, this is great. I was just thinking about, I'm with Verizon, I was just thinking about tying into the whole process from data sources to data consumption is the attribute-based access to the data and the focus on that we've talked a lot about through other sessions. You know, it kind of falls under the zero trust slogan, but really what it means is at each stage you've got to be able to ensure that whoever has access, their attributes for all of these points. So how did you look at where you build into that identity trust model?
Sure, I will tell you that we didn't specifically speak of that. I don't think I actually have any of my technical team out here. We didn't specifically speak to the data trust model, but I would say when I spoke about orchestration and I spoke about governance, you know, governance would set the parameters, orchestration would affect the mechanics of those access limitations or privileges that we would provide to users. And it would be driven, quite frankly, it would be driven by, if I'm to be practical, right? So truth be told, again, I'm an operator. If I'm going to be practical about it, what I'm going to be looking at is I'm going to be looking at classifying my users into role-based access so that they will be able to use their role-based access based on their operational or functional, not administrative role, their operational or functional role to be able to access that data to enable their aspect of operations. That would be my, you know, if I were a commander or a chief of staff or a designer of this, that would be the aspect that I would take, or the perspective I would take on that. Does that answer your question? Yes, sir.
You know, there's discussions about how determine data fabric. So did the Army give you like very strict definition, or you came to them and say, hey, that's what a data fabric is, and they never ask you a question?
B. I will tell you that one of the things, it's so an observation, right? Having done this for a little while, both in uniform and now in civilian clothes. What has been fascinating to me is to watch people as they have transitioned. If you have been coming to these for several years, right? You've heard the conversation, and it started with we need cyber, right? We're going to sprinkle some cyber on this stuff, and that's really going to help us. And then people realize the amount of data and the amount of analysis that is required to do cyber, right? Either on the offense or the defense. And they looked at it and they said, you know what we really need? We don't have enough humans with the capability to do this at speed and scale. We need some of this AI ML stuff, right? And we'll sprinkle out on top of the cyber stuff, and that's going to make it better. And now they're starting to realize, thankfully, that the AI ML stuff is nothing but algorithms until you train it. And where do you train it? And what does it eat for operational outputs? It eats data, right? So I think, and I am thankful, that that's where we are in our evolution of understanding, is that institutionally we are starting to understand the importance of data, and they're looking around and saying, our data's a train wreck. We need to get our arms around our data. We need to start to collect our data. We need to start to again, transform our data and refine it and put it into a format where we can actually now do the analytics that provide the insights for the outcomes we want. That's where I think we are. I do not think we are yet, we collectively, as an institution, have done the work to determine what that data fabric should look like. Quite frankly, I believe as our operational concepts are evolving, we need to evolve our data fabric concepts at the same time. And so when I was talking about making decisions of how, if I'm going to talk as a service about taking our enterprise capabilities, our enterprise network capabilities, and pushing them to the forward edge, I start to think about what our adversary is going to do in a DDIL environment. That is what leads me to ask the question, well, how much compute do I send forward? What data do I need forward, and what data do I need to send back given the limited bandwidth I have? What data repositories do I need to hold forward, and for how long? I think those are good questions, and I think they're questions we have not yet started to address. I think it's going to take operational modeling as we develop our operating concepts, and as we develop those concepts, we have to, in tandem, not only develop our data fabric, we need to test it, and we need to optimize it for those outcomes as an inherent part of those experiments. My opinion. Does that answer your question? Probably more than you wanted.
Hi, in the center you suggest that this is a multi-level security aware, right? Is that throughout the entire fabric? If I have sensors at different classification levels and users are cleared differently, how does that work in this fabric?
I think you're going to have to, at some point, be able to make those decisions about classification, right? Sensors are going to pick up sensor data. When I pull data off, say, an F-35, right, and it's going to have a lot of data on it, and I pull it back, I think the classification requirements for those data, that data is going to be pre-established. So the question is, where do we actually do, then when I pull that data down, where do we do the cross data, essentially the cross data exchange, right? Where do I have my CDS? I will tell you that is not a specific technical aspect that we looked at, but I think you're going to have a proliferation of cross-domain solutions where you can actually move that data to and from, unless the government is able to change the way they administer and essentially require those networks to be separated, or they change the access requirements based on operational needs. I think that's an operational and less a technical decision about a decision of where that access is going to be. I don't think we're ever going to get away from unclassed secret or TS, just a fact, but how we technically manage it and what those accesses are going to be, I think are going to be operationally driven. We didn't go into a technical solution for that. I just don't see it as realistic that we'll transition away from that in some way. Do you have, I'd be happy to hear if you have some thoughts on it, you've been thinking about it.
No, but I think that suggests that in the short term, you're going to have 3 fabrics, one for you, one for us, one for TS.
I think at some point you're going to have to divide the data and determine what fabric it goes into. I believe that is the only practical option right now, given the way we operate.
I would say that probably happens at the metadata labeling era, right? Because it's just metadata. So as you look at that data and you determine what classification, I think that would happen right there at that, when you're doing the labeling and metadata, whatever tool that is, or whether that's a human. I would think that at that point you're going to make a decision whether you put class, whether you put secret or something like that. You put some type of label that pushes it up to that upper network or lower network.
I think some of it is going to come. Some of it's going to be pretty simple, right? Measuring signals or mass in. You're going to be doing some mass in out there, right? You're pulling in that kind of data. That's not going to go unclassified, right? That's just going to come straight into the TS type level. So I think some of it, some of it's right. Some of it depends on the ingest and the source. Anybody else? All right, hey, I thank you for your attention today. I appreciate it and appreciate the opportunity to present what we have. Thank you.
We saw a lot of
Did you bring your own, or do they have yours on?